I'm going to try and give you a bit of an insight into how the WPA2 vulnerability that's just been discovered works. I won't be able to perform the actual attack because I don't have the tools to do that, but I'll just give you an idea of the concepts behind it and why it came about. Okay, what I've got here is just a simple capture with an AP on channel 1. I've just got a channel column here to show what channel we're on. And I come along with a client, this is my phone, which is an Android phone, oddly enough, which is particularly vulnerable to the attack. It does the usual things, probes around for the network, does the authentication, and then does the association. And then we do the four-way handshake. Now you can see that there. Once that's done, we can start sending data, and you'll see data goes around, and that's all good. This is a normal working network. Now, one thing to note is the attack attacks the key message 3. So what it does, it lets the first two key messages go through as normal, but then the attacker mimics a message where the AP tells the client to change channel. And I did that a bit further on here. So if we just go through after this normal data on channel 1, keep in mind we're all on channel 1 here. At some point I changed the AP to channel 6, and here we go. Now just before it changed to channel 6, there you see it's now on 6, in the beacon there's now a little field here called the channel switch announcement. Okay, and it's saying, it's basically the AP telling all the clients we're about to move to channel 6. Because if it didn't, the clients would still be hanging on channel 1. They don't know, they just lost their AP, they don't know any better. So the AP sends out a message saying, okay, here's our new channel. And it did that 4 times. That's configurable in this setup, but basically while it's still on that channel, channel 1, it says we're going to channel 6, and that's part of the beacon. Now when we're on channel 6, things can continue. There's no new four-way handshake, it's just we've changed channel. Now there's no need to do a reassociation, everything's the same, it's just changed channel. So what they're doing in this attack is they're letting I'll go back to the actual four-way handshake itself, here we go. What they're doing with the attack is they're letting key 1 message go through, which is from the access point to the client. Key message 2 comes from the client to the AP, but then before message 3 can go from the AP to the client, the attacker sends a channel switch announcement. It says go to a different channel. So that way when the AP does send that third message, the client's no longer on that channel to receive it. The client's gone and it misses that message, but the attacker gets that message. And then this acknowledgement that goes to the AP, usually when it gets that third message, was not there. So the AP will send it again. And now we've got 2 messages of a key. And then we go, the attacker will switch to the other channel as well and start putting that on the client. And the client, badly implemented, it'll use zeros for its encryption key. So it won't be encrypted basically. The attacker will be able to just see the data going through there. So we're not actually cracking the passphrase or anything like that, and it doesn't matter if it's a pre-shared key or an EAP network, because they both go through the four-way handshake, and that's where the vulnerability is. So to get around this, basically the client has to be patched. All the client vendors have to make sure that they're not vulnerable to this key 3 replay. From the AP's side of things, it can be prevented by, basically it's an IDS system. If the AP detects that between those keys there was a channel switch announcement, it knows it's under attack, so it can take action and not let that client do anything. So it can protect it that way. But that's in a nutshell how the attack works. And as soon as the tools become readily available, I'll try and do a demonstration of one.